Our next section, we will be solving logarithmic equations. A couple of things for us to remember here is that the first step would be to condense our logarithms, and that's going to be from everything that we did with our last section. So if you still have your note cards, you're welcome to use them here. We're also going to use the one-to-one property, and we talked about this as well. If log base b of x equals log base b of y, then x has to equal y. And then we're going to check for extraneous solutions. In other words, whenever we have a logarithm, we do need to remember that the graph of log x, or even the natural log of x, they both look very similar in that they do cross the x-axis at 1, 0, but then we never see a negative x value. We do approach the y-axis, and that y-axis will serve as a vertical asymptote for our graphs. And so notice there's no other portion on this other side over here. So your whatever is going to make this x value here negative, that needs to be thrown out. That's what's considered an extraneous solution. So we do have to watch out for that. With our first couple of problems, notice that we have our logarithms equal to each other, and notice it is log base 3 and log base 3. Since that is the case, we can just set up the equation 7x minus 1 equals 5x plus 17. And then we just solve our linear equation just like normal. We would subtract 5 over. We would add 1 over. And notice that x is 9. Now to check for extraneous roots, in other words, when we check this, we need to take 9 and plug it in here and here. If that generates a negative solution, then or a negative value, then we throw out that solution. And you can do this in your minds if you want to, or very quickly with the calculator. You see 9 times 7 minus 1. That is positive, so we're good there. And then 5 times 9 plus 17. And that again is positive. So there's no extraneous roots here, and my solution is x equals 9. Okay, our next example. Again, very similar. We already have this condensed. We have natural log and natural log. So we can just take our k squared minus 4k and set that equal to k plus 14. Now we do have an exponent of 2, so that means everything needs to come over to one side, and we need to set up some kind of factoring. So I have k squared. I'm going to subtract this k, and it's going to combine with the negative 4. That's going to make negative 5 minus 14. And so quick factoring, notice that our signs are different, and we've got to subtract and get a negative 5. So that's going to be a negative 7 and a positive 2. And again, just like before, we will set each part equal to 0 and solve. So k minus 7 equals 0, k plus 2 equals 0, and k equals 7, and then k equals negative 2. And just like earlier, we do need to check to see if I'm going to get a negative value anywhere in our argument. So I'm going to take 7, and I'm going to plug in, and notice I have 4k, or 7 squared, minus 4k, or 28. Notice that is going to be positive, and so I know that part's okay. And looking over here, if I plug in 7, I see 7 plus 14. That is still positive as well, so 7's okay. Now let's plug in negative 2. If I plug in negative 2, I'm going to have positive 4 minus a negative 8, or positive 8. So that is positive. And plug in negative 2 here. That's going to give me negative 2 plus 14. And that is also positive. So both 7 and negative 2 will generate a correct answer. Now for our next set of problems, notice we have more than one logarithm on one side. So this is where we're going to have to use our condensing rules. And a quick review there, and do use your note card. If you're separated with addition, you can condense this with multiplication, and you really need to do that first if you can. So we're going to have 4 times c plus 3 equals log 8. And now since that's condensed, we can set up our equation. 4 times c plus 3 equals 8. Now you're welcome to do this step in your heads. Just don't forget to do that step. You have 4c plus 12 equals 8. And so 4c is going to be negative 4, and c is negative 1. And again, once again, for every one of these, we need to check to see about our roots. So when we check this, notice there's nothing to substitute in here and here, but there is here, so we need to substitute negative 1 in for c. And notice, well, my goodness, negative 1 plus 3, that is positive, so negative 1 is okay to keep. All right, for our next problem, again, we are doing all of those rules, condensing. Remember subtraction, that did condense to be division. So we're going to say log base 7, and it's going to be the first term over the second. And then equals, and we did move this number in front up to be an exponent, so log base 7 of 8 raised to the 1/3. And now we're ready to set these arguments equal to each other. So I have w plus 6 over 5w minus 3 equals 8 to the 1/3. Remember that 8 to the 1/3 is really the cube root of 8, which is 2. Now to solve this you're going to set up like a proportion, and you can cross multiply. So we're going to say w plus 6, that's as a whole, times 1. So w plus 6 equals 2 times 5w minus 3. Do make sure you use the distributive property there. Most people just multiply the 2 and 5 and forget to multiply the 2 and 3. Now we're going to put everything together on one, or numbers on one side, letters on the other. So I have negative 9w equals negative 12, and so w is going to be positive 4/3. Okay, our next problem. Notice that on one side, on the left side, there's no condensing, but on the right side you have that 1/2. So we're going to move that up to the top. And so I have log base 4 of 4p plus 3, and that's equal to log base 4 of 16p to the 4th, all raised to the 1/2. And now we're ready to set things equal to each other. We have 4p plus 3 equals, now 16p to the 4th, all of that's in parentheses, so I need to raise each part equal, or raise each part to that exponent. 16 to the 1/2 means square root of 16, which is 4. And then exponent raised to an exponent, we multiply. 4 times 1/2 is 2, so I have 4p squared. Since I have that squared exponent, that means I need to move everything over with it and set up a factoring problem. So I'm going to have 0 equals 4p squared minus 4p minus 3. And so we need to do some factoring here. I think most everybody would like to do the slide and divide rule, so we multiply that 4 over. So we have p squared minus 4p minus 12. And when we factor this, it looks like we're going to get a negative 6 and a positive 2. Now don't forget, you did your sliding and dividing. You slid over the 4, so now we've got to come back and divide by this 4. And then set each part equal to 0. Notice that we're going to get p equals 6 over 4, which is going to be 3/2. Or p is going to be equal to negative 1/2. Now we have our two solutions. We do need to check these though to see if they're going to work. So let's go substitute in 3 over 2. And again, we're just looking at the sign. Usually students here, they get so bogged down in finding the actual number. We really don't care about that number. We just care about the sign of it. And so notice 4 times a positive, and then we're adding 3. That's going to stay positive. And then 16p to the 4th, no matter what I substitute in for p, notice I'm raising it to the 4th power, so that's always going to be positive as well. So that's going to work. And then if I plug in negative 1/2, we're going to have 4 times negative 1/2 plus 3. So the opposite of 1/2 of 4, negative 2. Negative 2 plus 3, that's still positive. And then the same is true over here with raising that negative 1/2 to the 4th. That's an even exponent, so it's going to stay positive. So again, we see that both solutions work. All right, so moving on to our next properties. First of all, it looks like we need to move this 2 up, and that's going to be an exponent here. So I have natural log of a plus 1 raised to the 2nd equals, and we're going to do a couple of things here. We know that means divide, so we're going to have the natural log of 80 over 5, and then that's raised to the 3/2. So that's some good review there. Let's go ahead and bring down our other side. Natural log of a plus 1 all squared equals, and then 80 over 5, that's going to end up being 16. And then we're going to take 16 and raise it to the 3/2. So let's go over here to the side and review that. 16 to the 3/2. That's going to tell us that the bottom is our root. So we need the second root, or the square root of 16, which is 4. And then I need 4 raised to the 3rd, which is 64. So finally, here we have a plus 1 all squared equals 64. A couple of ways you can do this. You need to full out the side, and I would go ahead and do that. I will show you both ways though. Let's go ahead and FOIL out, and remember that means you have to separate that and do a plus 1 times a plus 1. So I'm going to go ahead and write in that so we don't forget. This is an ACT thing that we tend to forget. So a plus 1 times a plus 1 equals 64. We do our FOILing. We have a squared plus a, so plus 2a plus 1 equals 64. Our highest exponent is squared, so we do need to subtract over our 63. So that's going to give us, or 64, I was thinking of the answer. That's 64, so when I subtract it over, I get minus 63. And then whenever I factor this, I'm going to have a plus 9 times a minus 7. And so we see here that a is either going to be negative 9 or a can be positive 7. Now we definitely need to go back and check and see. And notice this side over here, let me change for just a moment. This side over here ended up condensing down to just a number here. So there's really nothing to plug in there, but our variable is over here. So that we definitely need to go back and check. And the moment we do go check, notice if I plug in negative 9 into this part here, I'm going to have negative 9 plus 1, which is going to generate a negative 8 right there. Now, I know the 2 will square it, but that negative comes first. And so that means we're going to throw out negative 9. We need to plug in 7, and we see that 7 plus 1 is greater than 0. So 7 should be the solution we keep. The next type of problems that we're going to look at is going to be when we have a logarithm equal to a number. And so the big part here is once we condense and isolate the logarithm, we're going to have to change this to exponential form. You're still going to have to solve, and we still need to check for those extraneous roots. All right, so looking at the first one here, again, we already have this condensed down to one logarithm. Now in our exponential form, we said that our base here 2 raised to the 7th, because all logarithms were equal to exponents, would have to be equal to 3x minus 4. So again, that was saying 2 raised to the 7th is equal to 3x minus 4. You kind of make a loop there. And so here, solving this, 2 to the 7th, that's going to give us 128 equals 3x minus 4. We're going to add 4 over, so we have 132 equals 3x. And if we divide both sides by 3, we should get 44 equals x. All right, so, and again, let's go check and make sure that solution makes sense. Make sure we don't have any negatives here. So we're going to say 3 times 44 minus 4. That is still positive, so that solution will work. All right, so for number 8, and this one, we can do a calculator, but I had rather us leave this in exact form. Now, do remember a little bit of review here, natural log. That was log, where our base was stuck at e, of 2a, and that's equal to 9. If we remember that, then we're right back to that same process. We're going to say e raised to the 9th power is equal to 2 times a, and then we're going to solve for a, which we're going to divide both sides by 2, and notice that e to the 9th over 2 is going to be what a is equal to. Now this is what I mean by leaving it in exact form. I don't want y'all to simplify any further than that, and to check your work, it's still not too bad. E to the 9th over 2, keep in mind that's going to be multiplied to 2 if we plug in. So here, notice those 2's do cancel, and we're left with e to the 9th. And a bit of a review there, e was equal to 2.71828, repeating. So this e is always positive there. Okay, for our next problem, again, we're going through and we need to isolate our logarithm, so we're going to add this 5 over. We've not seen a problem quite like this one, but you would still try to get that logarithm by itself first. If I add that 5 over, we're going to have a 2, and then we're back to our same steps. We're going to change to exponential form. So 6 to the 2nd equals w plus 7. So we're going to have 36 equals w plus 7, and if we subtract 7, we're going to have 29 equals w. And we do need to go back up and check, and the only place we would have that variable is here, and I see that 29 plus 7 is still positive, so it is okay. All right, for our next problem, we have a lot of stuff here. Now, again, you are still going to try to isolate your logarithm. So, in your mind, if you want to pretend that is just one ginormous x that you're solving for, nothing wrong with that. In algebra, y'all were told you would need to move that 4 over. So, I'm going to have 2 log base 9 of k squared plus 2k equals 1. Then we're going to divide both sides by 2. And so we're going to have log base 9 of x squared, or k squared plus 2k, and that's going to equal 1/2. We're moving that 2 over to this other side, and now we're ready to go to our exponential form. So we're going to take our base 9 raised to the 1/2 power, and that's going to be equal to k squared plus 2 times k. And we need to go through and simplify 9 to the 1/2 power. Do you remember that means square root? So the square root of 9 is 3 equals k squared plus 2k. Since I have the square term, I need to move 3 over and factor. So I have k squared plus 2k minus 3. And this will factor into k plus 3 times k minus 1. Now if we set each part equal to 0, we're going to have k plus 3 equals 0. And then we have k minus 1 equals 0. So k is negative 3 or k is 1. Now we do need to check to see, are we going to generate any negatives here? And again, we're just checking where we would substitute in. And so for our first one, let's check k equals negative 3. So we're going to have negative 3 all squared plus 2 times negative 3. And so that looks like that's going to give us 9 minus 6, which is positive. So k can be negative 3. And let's plug in when k is 1. And so we're going to have 1 squared plus 2 times 1. And that very quickly we see is positive. So we have two solutions here. Okay, for our next problem, again, notice we have two separated logarithms. We do need to condense those. Since we have addition, this will condense to multiplication. So we have 2v plus 3 times 2v minus 3, and this is equal to 2. And now we can go ahead and do a couple of steps if you want to. This is going to go to exponential form. So we have 4 raised to the second power is equal to this product. So we have 2v plus 3 times 2v minus 3. And we do need to multiply some of this out. So we're going to have 16 equals, and here we need to do our FOIL, first, outer, inner, and last. So we're going to have 4v squared. Our outer term is going to be minus 6v, the inner term positive 6v, and then the last minus 9. Notice that those middle terms do cancel. And then I need to subtract 16 over because I have a squared term, so everything goes on that same side with it. So I subtract 16 over and I get negative 25. Since this is a factoring problem, again, that squares what this is telling me. We only have two terms, and notice something squared for both terms. Well, what's being squared for 4v squared? That's 2v and 2v. And let's see, we have a negative, so we know we have positive and negative. And what's being squared to get 25 is 5 and 5. So now we're ready to set each part equal to 0 and solve. So 2v plus 5 equals 0, or 2v minus 5 equals 0. If I subtract 5 and divide by 2, I have negative 5 halves. And if I add 5 and divide by 2, I have positive 5 halves. And again, we need to come back up here and we need to check. And we need to check at each individual spot. So that gets tricky because sometimes we like to check down here where we're multiplying, and we don't need to. We need to check individual. And so whenever I go, let's start with negative 5 halves. So if v is negative 5 halves, it looks like we might get a negative here. We have 2 times negative 5 halves over 2 plus 3. And for that portion, notice the 2's cancel, but I have negative 5 plus 3. So that's less than 0. So that tells me negative 5 halves cannot be a solution. So now we need to check positive 5 halves. And sometimes both solutions get thrown out. So we have 2 times 5 halves plus 3. Very quickly, that we see that is positive. Now what about 2 times 5 halves and then minus 3? And we see that we still stick with a positive, so this solution will work. Now if both of those did not work, we would just have no solution there. All right, for our next problem, again, we need to go through some condensing for sure. We're going to move our 1/3 up. So we have natural log of 27 raised to the 1/3 plus natural log of x minus 5 equals 4. And here we know natural log of 27, that means the cube root of 27, which is 3. And then I know with addition, I condense to multiplication, so I'm going to go ahead and put that as x minus 5. All of that equals 4. Now do remember natural log, that's log base e of 3 times x minus 5. Now, if you remember that's log base e, you don't have to write in this step. You can go straight to that. And then we're going to straight to the exponential form. So you're going to have e raised to the 4th equals 3 times x minus 5. Now, I do want you to keep this e to the 4th in exact form. I don't want any decimals here, because most of the time you will always see this kept in exact form, just like with pi. So we have 3x minus 15. We're going to add 15 over, so we have e to the 4th plus 15 equals 3x. And then finally, we're going to divide by 3. So notice our solution, x equals, and this looks terrible, but we can make it through it. And all of that is over 3. Now let's go back up and look at substituting in. And up here we have the problem here. This one was just a number, so x minus 5. So we need to think about all of this and see, well, what about here to check this x value? Let's just go ahead and write in a check here. We can see pretty quickly this is going to stay positive, but let's check it out just to see, and we'll see why. We can think of this as divided up as e to the 4th over 3 plus 15 over 3, and then I need to subtract 5. And if we see 15 over 3 is the same thing as 5, so those cancel each other out, and so we're still positive. So all of that disgusting looking answer is going to be kept. Okay, so for this next problem, we are going to have to combine these with multiplication. So I have log base 2 of n minus 3 times n plus 1, and that is equal to 5. So we can go ahead and change to exponential form. So we're going to have 2 raised to the 5th power is equal to, and let's go ahead and FOIL this out while we're at it. So we're going to have n squared plus n minus 3n minus 3. 2 to the 5th is 32 equals n squared plus, or I'm sorry, minus 2n minus 3. And then we're going to subtract 32 over, and looks like again we have a good factoring problem here. 2n minus 35. And so when we factor this, we should use factors of 7 and 5. And again, setting each part of that equal to 0, we see that we get n is 7 and n is negative 5. Now we do need to go check our answers once more. And if we check these, if we let n be 7, then we have 7 minus 3, and then we have a 7 plus 1. So 7 looks like it's okay. But when n is negative 5, from this first portion here, we have negative 5 minus 3, which is not positive, so negative 5 gets thrown out. Right, our last example, we are again going to have to condense this before anything. So when we put this together, we have log base 2. We have subtraction, so we're going to stack these, and the first one's on top, second one on bottom. All of that's equal to 2. And now we go to exponential form, so 2 raised to the 2nd power is equal to c squared over 3c minus 5. Here we can cross multiply these two. Think of 2 squared, that's going to be 4 over 1. So if I cross multiply here, I have 4 times 3c minus 5 is equal to c squared. So now it looks like we have a problem to set up and factor. We're going to do our distributive property, so 12c minus 20 equals c squared. I am going to move everything over, so I have c squared minus 12c plus 20. And so when we're factoring these, notice we need the factors of 20. Now we're going to add those to get 12. So it looks like we're going to have to use 10 and 2. And both are negative to get that negative 12. So we're going to say c minus 10 times c minus 2. Setting each part equal to 0, we have c is 10 or c is 2. And again, we do need to check those. And I think very quickly we could glance back up to c. If we substitute those in, whether or not we get a positive or a negative. And of course, this term here, c squared, that's always positive. And then here we're going to say 3 times c and then minus 5. So both of those do turn out positive. So both answers do work.